So before we go on to talking a little bit about the flow of control of executing Java programs, I want to just take a moment and revisit the idea of encapsulation. Remember that encapsulation is this idea that each object keeps track of its own information. So let's go back and look at our die class here. How we supported encapsulation is we kept face value private. What that means is that some outside class, so this die tester class is a client class. Okay, so die tester is the client. We talked a little bit about clients before. It uses the die class, so it uses it by creating objects of type die and invoking methods on those objects. So die is the class, it's the blueprint, and die tester is the client. Now, the idea of encapsulation is that the client cannot directly access the instance data variables of the object. So I cannot, for example, print out d3.faceValue. I can't do that. If I try to do that, I'll get a compiler error saying that this variable is not visible. If I had made this public, I would be able to do this. This would be allowed. I'd be able to directly access it. This violates encapsulation. We don't want to do this, but I'm just showing you what would happen if I did do that. I would be able to directly access face value. Now, the danger of that is that I could do things like saying d3.faceValue gets -10, and I could set the face value on d3 to be -10, which doesn't make any sense. But because it's a public variable, I can do that. I can access it directly as a client, and I can set it to whatever I want. So by keeping this private, we prevent that from happening. We can't directly access it. Now, you might be thinking, well, okay, sure, I can't directly access it, but what I can do is I can just say, hey, let's just invoke the setFaceValue method and send in -10. Doesn't that do the same thing? I've essentially set the face value of my die to be -10. So I haven't prevented that just by making face value private. And that's true with the code as we've written it right now. But what we are going to do from here on out, moving forward, is we're going to put validity checks inside of our setter methods. Now, not every setter method will need a validity check, but many will, particularly ones that take in numeric parameters that are associated with numeric variables. So here, for example, what we want to do is we want to make sure that the value you're giving me is a good value. Now, what defines a good value for a die? Well, that new face value has to be greater than or equal to 1, and it has to be less than or equal to, oh, and look, we have a constant here that we can use, number of sides, which actually I never remember to set back to 6. I'm going to do that now. So here we're saying, hey, if the value you send in as a parameter is greater than or equal to 1 and less than or equal to, number of sides, then it's a valid value. So I'm going to go ahead and update the value of the instance data variable. But if it's not, I'm not going to do anything. I'm just going to ignore it. I'm just going to say, hey, you know, I'm not changing anything. So now what happens here when I try to do this? Well, setFaceValue will be invoked. -10 will be sent as a parameter, but -10 is not going to pass our validity check, which means we're never going to get inside this if statement, which means this line here is never going to be invoked. So now there actually is no way for a client to set the number showing on this die to be anything that's invalid. There's no way to do it. Remember, if this was public, there'd be a way to do it. And if I didn't put a validity check in here in my public method, there would also be a way to do it. But since I keep my instance data variable private and I put some validity checking inside my setter method, I'm protected now. There's no way for a malicious client to come along and do something like setting this to be an invalid value. So now that we see how we create objects and how we can invoke methods on them, hopefully you're starting to see the benefits of encapsulation. And again, that idea is we're letting each class and each object protect its own information, and we're restricting the values that that information can take so that they only make sense for that particular class.